All right, here is the exciting discussion on the families and groups and periods of the periodic table. This is our current modern periodic table. You'll notice that this one's long and skinny compared to the one we have in our classroom. It's just organized a little bit differently, and this one is quite colorful. But let's talk about a little bit of history first. There was this Russian scientist named Dmitry Mendeleev, and he was the first to start organizing elements according to their atomic mass or atomic weight. You'll notice that he has several of them in here that are missing, that have little question marks. And this is not his original handwriting. This is what somebody else had typed up from his handwriting. And he knew that there were elements missing that were probably out there, and so he developed this chart so that they could start recognizing where different elements were located in this organization, and figure out where the missing ones where that they would be located. You'll notice that these elements are arranged according to their atomic mass or weight, and we now in our current model of the periodic table, we organize it according to its atomic number. You'll notice that this one is also organized according to Niels Bohr's model with the energy levels, and even the more current model of the modern atomic theory with the electron clouds and orbitals. You'll also notice that there's these bottom two rows that are separated. They fit in the periodic table right after element number 56, barium, and the one below it. They make it like this so that it is a little bit more convenient to put on a piece of paper. Otherwise, it'd be this long, skinny periodic table at the bottom with the lanthanide and actinide series placed within it. Otherwise, we basically have the top table that we always refer to in our chemistry class. Now, the periodic table is organized by groups or columns. And for example, right there is the very first group or family. Here's another group. This one is manganese's family, boron's family, and the noble gases. Now again, groups or families, they go vertical. That is how they are organized. But there are also periods. Periods are organized horizontally. This is the first period of the periodic table, and you can see there that there is hydrogen and helium within that period. The fourth period, there's 18 of them. And then this period, when you go and you add that bottom lanthanide series to the whole table, you'll find that this one is actually 32 elements long. It is, again, made this way so that it is more convenient for it to use, because we basically use most of the natural elements that are in the top portion of it. So periods are arranged horizontally. Now there are different colors on this periodic table, and we need to recognize the different families, and they are shown in different colors on this periodic table. The very first family, we call them the alkali metals. This family has several elements that are highly reactive. The further down the family you go, the stronger the properties are of being highly reactive. They can't be contained in anything near water, so they have to be put in mineral oil so that water molecules don't touch them, because they will start reacting instantly with. In fact, these are probably the most reactive metals on the periodic table. The next family, it is also reactive, but not near as reactive as the alkali metals. These ones are called the alkaline earth metals. And next to the alkaline earth metals is the transitional metals, or transition metals. They're called either one, I've seen them. And there are individual families within them, but we name them by their representative element, like number 29 there, copper. That is the representative element in that vertical family, and so we'd say that that one is in copper's family. And that just so happens to be the family that has the best electron configuration for a conductive metal, a good conductor. Okay, there are other representative elements up at the top there that we can recognize that that's boron's family, carbon's family, nitrogen's family, oxygen's family, And fluorine's family has another special name too. These ones are the halogens. The halogens are gases and liquids too that are reactive. They are missing one electron in their outermost valence shell, so that they are pretty reactive trying to fill that orb. The last family on the periodic table is the noble gases. The noble gases are very non-reactive. They are inert. They don't react with things, except for krypton and xenon. They have had them form compounds, but basically they're inert. They don't react with anything. Now there is a staircase on the periodic table. You'll notice that brown one there, and I've now highlighted it. The staircase separates metals from nonmetals. Hydrogen does not fit in this pattern with metals and the nonmetals, so basically it has to go over on the nonmetal side, but all the rest of them over there are metals. Even in our family names, we said alkali metals, alkaline earth metals, transition metals. Those are all metals. And those blue ones underneath the staircase, those are also metals. The ones to the right of the staircase are nonmetals. Metals have a luster. Many of them are silvery. Some of them can be colored, but you'll notice them because they shine lustrous and they are malleable, and they also conduct electricity well. And that is not everything is the opposite of that for nonmetals. They're brittle. You can't hammer a shape into them because they just break apart. They don't conduct electricity well, and they are not lustrous at all. And then there is the elements on the staircase, which we call the metalloids. In some texts, they call them semi-metals, but I call them the metalloids. And they behave like metals and like nonmetals. Like, for example, silicon, it conducts electricity, but it still also behaves like a nonmetal too. Again, that's how it is organized. The staircase separates the metals from the nonmetals. Okay, again, there's those two series on the bottom of the periodic table, the lanthanide series and the actinide series. They fit right inside of those transitional metals. Right there they fit. Okay, they fit right in there so that we can even say that they are inner transitional metals because they fit within the transitional metals. Okay, also if you look on your periodic table that I gave you, that's the blue and red and black periodic table from Sergeant Welch, if you look at that periodic table, you'll notice that some of the elements are black, some are blue, some are red, and some are also just outlined. The red ones show that they are a gas at room temperature. The blue ones show that they are liquid at room temperature, and I bet that you can guess that the black ones are solids at room temperature. The outline ones are they're man-made, they're synthetic, and most likely they are solid at room temperature, but I honestly do not know all of them. I've only seen a couple samples in some really neat periodic tables otherwise. And that is all we have for the organization of the periodic table. Make sure that you practice these on some blank periodic tables, and we'll be taking a test on this soon, and then later on this year we will talk about individual families and how that they are, what their properties are.